All right, so here's part two of our section 11.1 video here on the difference between two population proportions, and we're focusing on confidence intervals here because there's a strong correlation and association between the outcome of a hypothesis test for the difference between two samples and the information we get from the confidence interval between the difference of two samples. So we have our conditions just like we did before. And our confidence interval formula is right down here. There's our confidence interval formula, where we use each proportion in not only the first part in the point estimate, but also inside the standard error. So I thought it'd be easier just to go ahead and answer a couple problems here using the calculator to kind of get things going. So metastatic melanoma is a certain type of skin cancer that's very bad. Bristol Myers Squibb has come up with a drug to try to extend a patient's life, the survival rate of the patient, the amount of time. And so, typically survival rates for patients with this cancer is 6 to 10 months. Historically, patients with metastatic melanoma were treated with chemotherapy and the dicarbazine or buzine. Now, they did, with Bristol Myers, did a clinical trial of 418 patients who had the melanoma, and they were randomly assigned to two groups. The first group got this new drug called the Opdivo, 210 people in there, and then the other 208 were in the dicarbazine. After the 3 weeks of the 210 people, 10 people that were in the first group, 45 had survived to 12 months. And then of the 208 patients in the other group, 22 of them survived for 12 months. So, they increased the, from the standard of 6 to 10 months to up to 12 months. So what type of experimental design is this study? It is a completely randomized design. It is a randomized design. What is a response variable? Is it quantitative or qualitative? So it is it is qualitative, and the response variable is death. When did they die? So 12 months, 10 months, whatever. So it was qualitative because, again, it's not numerical. What is the factor that is controlled and set of various levels? It was the factors was what type of drug they got, and there was basically two. There's two levels. How many levels are there? There's that one, 2 levels. Sorry, squeeze it in there, didn't need to. Now they asked us to estimate the difference in the proportions. So that's where I'm going to do my 2 prop Z interval, because again, we're doing a confidence interval for the difference in proportions. So let's split my screen here. Stat over to test. It'd be a 2. There we go. 2. It'd be option B, 2 proportion Z interval is what we want. So this is option B on the calculator. And let's go ahead and press enter. And then while we just got to type in our information, they told us that 45 of the 210, and of the other one, 22 out of the 208. And then we did a 95% confidence interval, hit calculate. So our interval is 0.0304 and then 0.17799. So now they ask us to kind of interpret what that means. So what we're saying here is we are 95% confident that the interval of 0.0304 to 0.17799 contains the true difference in the proportion of patients who had survived 12 months in the OP-DIVO group versus the carbazine group. Okay. Minimum sample size. We did this earlier. We typically only have to do minimum sample size when we're dealing with confidence intervals. And we learned earlier that as we're doing this, if we can use a previous study, then we use what they have here. Now it happens to be for both samples is what it ends up being. Now if they don't tell us any prior studies or prior estimates, then we use 50% for both of the P1s and P2s. So that's what they have us do here in the next couple examples here, is just having us determine the minimum sample size for these situations based on they want a certain margin of error with a certain confidence interval. Now I see this one has a 90, so let's go through it. It says a physical therapist wants to determine the difference in the proportion of men and women who participate in regular sustained physical activity. What sample size should be obtained if she wishes her estimate to be within 3 percentage points with a 95% confidence interval. Now, assuming she uses the 1998 estimates, what would be the minimum sample size? So again, first off, margin of error is 0.03. We have a 95% confidence interval. So our Z-star, we've used it several times, would be 1.96 is what our Z-star would be. And we're going to go ahead. Here is my P1 hat and my P2 hat. So as I set this up, again, here's the generic formula. Margin of error greater than or equal to the Z-star square root of P1 hat times 1 minus P1 hat over N1 plus P2 hat times 1 minus P2 hat over N2. All right. So margin of error 0.03. Z-star 1.96 square root, and this one's going to be 0.219 times 0.781 over n plus 0.197 times 0.803 over n. Now, I took away the N1 and N2 because in order for us to figure this out, we're going to have to combine these two fractions. They're going to have the same denominator, and that's going to be our total sample size is what we're doing here. Because they don't give us enough to split it up between the two to say, for those. So it's going to have to be the same total sample, and then we can divide it in half for men and women. So as I do the math, we're going to divide over the 1.96. And then that gives us 0.03 over 1.96. Got to be greater than or equal to I'm going to get a combined answer here. I'm going to go ahead and I'm going to go find each one of those tops. Now we know we're basically get to just go ahead and add the two fractions together. So I'm just going to make this easier and say, okay, what is 0.219 times 0.781? And I'm going to add the other numerator, 0.197 times 0.803. So that gives me 0.33142 on top. Now we want to square both sides. And then that gives me 0.030 over 1.96 quantity squared is greater than or equal to 0.33142 over n. Now we talked about this in a previous lesson. I'm just going to make it this as easy as I can. I'm just going to, through inverse operations, I'm allowed to trade those two things. The n becomes over here. So it's n is greater than or equal to 0.33142 divided by that fraction. And I did that just this way so it's easier for me to type it into the calculator. All right, so what is alpha? Give me a fraction, 0.33142. On the bottom, I want another fraction. I want to go ahead and say 0.03 on the bottom, 1.96. There you go. That, oops, sorry. There we go. That's better. That looks good. And I hit enter. And this tells me that n has got to be greater than or equal to 1414.6. So we would say it's got to be bigger than 1415. We always round up here. So we got to do more than 1,415 people. Now they ask me, what if she doesn't use any prior estimates? So that changes it to where we basically have inside of our P1 hats, it's actually 0.5. So what that's going to do, that is going to give us, if 0.5 times 0.5 is 0.25. So if I look at our fraction, 0.03 greater than or equal to 1.96 times 0.25 over n plus 0.25 over n. So really the inside of the square root is really 0.50 over n. So I'm going to kind of change this. So all that's really changing is this top number right there. It's the only thing changing. And I'm going to change it to be a 0.5. So in this case, for the second case, if we don't have a point estimate, then we got to be greater than or equal to 0.50 over that fraction. And then I'm going to make my life easier and hit second enter, go back up to the numerator, and I'm going to change that to just 0.5. And then hit enter. And this one is 34.2. So we would say 2135. All right. So now, why did it increase? Well, our P hats went from like something low at 19% and whatever, 21%, 19% to now 50% for both. So that's the maximum we would want to do. That's the maximum we would need to do to have it, to get to hit our numbers that we needed to get our margin of error at 3%. And last video, educators want to determine the difference between the proportion of males and females who have completed 4 or more years of college. What sample size should be attained if they want a minimum 2% margin of error with 90% confidence interval? They're going to use the 1999 estimates. Then we're going to do it again with no prior estimates. So, as we set it up, again, our margin of error is 0.02, greater than or equal to our Z star, 90% confidence interval. Let's double check that. So again, how we would do that, we're going to use inverse norm. So second var is option 3. We would take we would do 1 minus 0.90, which was 0.1. and divide it by 2, which is 0.05. So 0.05, and then go all the way down. And my Z star is 1.645, so 1.645 times the square root, and now this is where we get to put all that other stuff in there. So I need more room to write here, I'm sorry. So we're gonna have 0.275 times 0.725 over n plus 0.231 times 0.769 over n. And then we're going to divide over the 1.65, so 0.02 over 1.645. We know we need to square it, because we got to get rid of the square root. I'm just trying to speed up process here. That's over n, so I need to go to the calculator and multiply the two sets of decimals and add the numerators together. So 0.275 times 0.725 plus 0.231 times 0.769, and that gives me 0.377014. Again, as we mentioned earlier, these two things trade places, so n has got to be greater than or equal to 0.377014 over our fraction squared. So on the bottom, another fraction, 0.02, 1.645 squared. Yeah, that looks pretty good. So it's got to be more than 2550.52, so this would be 2551. It's got to be more than that. Then they asked me in the second part, what if we don't use a prior estimate? Well, we practiced this in the problem before. Really, that's all going to change is this number right here. So no previous prior estimates or whatever means I'm using 50% for my P1 hat and my P2 hat. So that means my problem changes to be that n has got to be greater than or equal to again, it was 0.25 times 0.25. Add another of those together, which comes out to be 0.50 over our fraction of 0.02 over 1.645 squared. So I'm gonna tell it to put the last calculation, go up, and oh gosh, that's gracious. There we go. And so in this case, our sample size is going to be greater than 383. Is 3,383 is what it's got to be bigger than.